All right, welcome back to Mr. P Helps with Calculus. This is Unit 1, Day number 10, and we're going to be talking about IVT, otherwise known as the Intermediate Value Theorem, which is honestly quite a simple concept once you break it down into, it really just makes sense. I know when you read all this, it might confuse you a little bit, but my job is to make that as easy as possible as I can. So what IVT states is that if a function is continuous, and you can see this red function right here, that's going to be our function for this example, happens to be continuous. There are no breaks. Every single place from here to here, from A to B, is continuous. And it does include both endpoints. Therefore, stating that if f of A and f of B obviously have to have different heights, which they do, it doesn't matter which one's above the other, does not matter. As long as one is higher than the other, then it can be used. And therefore, what it's saying is basically that there has to be, in between A and B, some sort of point that meets every single height in between f of A and f of B. Now, I know I just used kind of the same jargon that you see on the screen. What that really means in layman's terms is if the function starts all the way down here, let's just say this is at 1, because that's what the little increments say. And let's say that B is ending at what looks to be about 5. Well, if f of A is 1 and f of B is 5, then every height in between 1 and 5 has to also be hit at some time over that interval. Now, does it have to be exactly right here? No. But what C is saying is that somewhere over this time, in between A and B, every single height, in this case n, would have to be hit. This height would have to be hit, so is this, so is this. Now, could a function hit that height more than once? Well, sure, a function could go, it could go up, it could go back down, and then go back up again. Now, it's possible that the height n could have been hit 3 times, or 5 times, or technically an infinite amount of times. But all IVT is proving is that if a function is continuous, and f of A and f of B don't equal the same thing, then every height in between f of A and f of B must be hit at some point. Now, let's look at some cases where it's not continuous. Well, if it's not continuous, why doesn't IVT occur? Why can't it be used is what I should say. It can't be used because maybe it starts at f of A, starts at f of A, B ends at f of B, but there's this jump in the middle where nowhere in this piecewise function did it have a height of n because it wasn't continuous. So because it wasn't continuous, you cannot guarantee the height being n at some time over that interval. So IVT cannot be applied to this graph. Now, if you look at this one, I kind of already explained this, but I might as well do it again since I have a nice little graphic now. That sometimes a function can go up and down multiple times, technically an infinite amount of times. So there's no rule that states how many times it's got to be that height. All IVT does is prove that it must be that height at some time. And you can read through this. This is pretty much the same information that I've just provided you. So let's look at some examples, because this is kind of what you're going to see on the AP exam. Now, on the AP exam, if they give you a table, they're going to have to give you some information up here. And this is very important. You cannot look this over because it says that the function is continuous. Had this not been stated in the question, IVT could not have been applied because one of the rules to IVT is that it must be a continuous function, and a table of values does not tell you anything about what's in between 0 and 2 or what's in between 2 and 4. So since it doesn't tell you anything about what's in between those values, it has to tell you up here that it's a continuous function, which it does. So therefore, why can IVT be applied? Well, it says, therefore, there exists some value of r. R is just some sort of value in between 0 and 2. We don't know what it is. It's some sort of value of x, for which f of r would have to equal 5. Well, does there have to be equal 5? Well, just because it's between 0 and 2 doesn't necessarily mean that. But what's also important here is that 5 is between the height of 7 and 3. So this function is starting all the way up here at a height of 7. It's ending at a height of 3. It's a continuous piece. So yes, every height in between 7 and 3 has to be hit at some point. Yes, IVT does prove that the height of 5, f of r, there has to be a time in between 0 and 2 where a height of 5 does exist. We have proven that using IVT. All right, looking at the next question, we have another piecewise function. This time they're just giving us the actual functions themselves. So you might get tables, you might get graphs, you might get functions. There's all different ways you might see the questions set up. It says, let k be the function defined by k of x. Piecewise function, there must exist some x between 0 and 2 for which k of x equals 4. Now notice how I'm writing the questions, writing the answers. Yes, on the AP exam, this is what's expected of you. This is an FRQ, free response question. You're going to have to explain why IVT can or cannot be applied. First thing I'm always going to look for, is it a continuous function? Well, clearly you can see my answer ahead of you that it's not. Let's see why. The reason why is because if I put 1 into this piece, I get 3. If I put 1 in for x here, I get 5. So it looks like this piece ends at a height of 3. This piece takes over at a height of 5. So this is not a piecewise. 1 is, trying to get on the graph, 1 is up here at 5. And this piece right here is ending at a height of 3. So that's not continuous. So therefore, IVT cannot be applied. Just like that first or second graphic that I showed you earlier, it showed you that jump discontinuity means that you might have overpassed that height. Not saying it's not, I'm not saying that it never hit a height of 4. It could have hit a height of 4, and I'm not even going to look into it. Yeah, it could have, but I can't use IVT to prove it. All right, example number 3. Now we're given an actual equation, no more piecewise. It says, does there have to be an interval of s of a of 3 between 0 and 1? Okay, couple things I need to prove here. Since I don't have any answers, I need to actually find s of 0 and s of 1. I need to find what was the height at the end. What's the height at the beginning of the function? What's the height at the end of the function? That's important to me. So it has a height of 0 at the beginning. It has a height of 6 at the end. 3 is in between 0 and 6. So far it's looking pretty good. Now, if you've kept track, I kind of didn't follow the same steps I did a second ago. I bypassed whether or not it's continuous. That is very important. Now, you might be asking yourself, well, hey, wait a second. Why did I say it was continuous? It never said so in the question. But what you should know about this question is it's a quadratic function. And quadratic functions, you know, look like a parabola. Now, it might not look exactly like this, but it's going to look something like this. And therefore, the domain is all real numbers. So yes, it is going to be a continuous function because all quadratic functions are continuous functions. And the only thing that you have to also say is that s of 0 and s of 1 are not the same. Now, I'll be honest with you, this, I don't always put this because this proves this. As long as you don't put the or equal to's here, then you're kind of also saying that this and this are not the same. If you put or equal to's here, then you must also include this. And hopefully you see what I'm talking about. Because without the or equal to's, then if this is in between, if this is greater than this and also less than this, then it's impossible for these two to be the same. Now, whichever way you decide to do it, it doesn't matter as long as whatever you write is logical. Example number 4. All right, it says, does there have to be some sort of value of x from 0 to 4? Can IVT be applied? First thing I always check is whether or not it's continuous. I'm going to plug 2 into this piece and get, what is that, 3, plug 2 into this piece. It's pretty easy. I get -1. Well, that's kind of a easy out right there because, yeah, even though at v of s, even though 1 is, actually, it doesn't meet either criteria, does it? It's not a continuous function, so therefore IVT can't be applied. And 1 is not in between v of 0 and v of 4, so there's 2 reasons why this cannot be used at IVT. All right, number 5. Which of the following statements must... I'm going to skip that one. That one is, honestly, it's just really... It's a logical question if you think through it. I don't think you're going to get a question like that. It's just a good question to think about logically. Use IVT to show that a polynomial function, once again, the key here is it's a polynomial function. It's a cubic function to be exact. All cubic functions are continuous. Cubic functions, if you don't remember, look something like this. Always be continuous. Now, it might not look exactly like this. I do know it's going to increase the entire time because it's a leading coefficient of a positive number. Now, first thing I would do is find what is f of 0 and f of 1. Since I already know it's a continuous function, the next thing I want to do is make sure these two aren't the same thing, which they're not. The last thing I need to do is figure out, well, hey, is what I'm looking for in between -1 and 2? So I wrote, use IVT to show that the polynomial function has a 0. Oh, okay, so we're looking for, does it have a 0? Well, 0 just means it says that f of something happens to be 0. So f of a happens to be 0. Or actually, f of c would have ended up being 0. F of c, here we go. So would f of c, could it be 0? Is 0 in between -1 and 2? Which it is. Yes, it's a continuous function. 0 is always going to be in between a positive and a negative. That's just one way you could word it. Now, you could use inequality, like I said before. I also stated f of 0 and f of 1 are not the same thing. Clearly, -1 and 2 are not equal to each other. All right, so I had one more. Once again, this is a very similar question to the last one. Root just means 0. So once again, we're looking for a 0. Is there a 0 in between -16 and 20? Yes, because I've already solved for g of 1 and g of 7. Yes, IVT can be applied because it is a continuous function. I know that because it's quadratic. And I know 0 is always in between a negative and a positive, which is something you're going to use a lot in future units when we start talking about critical value points. All right, thanks again for watching, and I will see you in the next video. Have a great day.